what this means is I'll post these notes. I apologize, everybody. I haven't been recording this lecture, so I'll post these notes. Is that the problem with having a skewed distribution is, if you remember when we compared those normal distributions and how they overlapped with each other and whatnot, is that when we have a skewed distribution and we're trying to figure out if they're different from each other or not, if they're skewed, they're not going to statistically give us any information, okay? So in this situation, if you remember last week, I talked about what's called a power analysis, okay? And if you remember, a power analysis in the end tells us what sample size we need, okay? And so if we end up with a skewed distribution, let's say we went and we're doing some survey and we're looking at two groups. Let's take Gabe's example. He brought, because, you know, okay. I think it was Gabe. Let me make sure I'm getting names right. Yeah, it was Gabe who brought up different color of hair, okay? And let's say, because I know about this with other things, so hair color and helping behavior, okay? So let's say in this situation, and I'm going to use Gabe as the name of the researcher, he wants to know is if people help more dependent upon your hair color. So let's go with people are more willing to help if your hair, here, well, okay. Okay, so here's kind of the example we have, okay, is hair color and helping behavior. Helping behavior is your dependent variable because that's what you're going to measure. Hair color is going to be the categories you put them. That's your independent variable. And we think the independent variable influences the dependent variable. And your hypothesis is individuals with darker hair will receive more help than those with lighter hair. And I put in here blonde/redhead, okay? Red hair, I apologize. And so let's say he went and sampled 50, no, let's go 100. Let's go 100 people so that we have plenty of hair colors. And he found that, let's say, blondes were skewed left, redheads were skewed right, and then let's go ahead and say that the darker haired people actually ended up in a normal distribution. What's the problem with comparing these variables with each other? I'll open up the chat, and there is no wrong answers on this. But why do you think if all of these distributions were not normal when we did the comparison and they were all skewed, why do you think that would be too much error to then analyze to see if there were actually group differences? Diana, you have your hand up.
Not everybody has their natural hair color.
that's true. That definitely could have influenced it. So there's again a confounding variable that may have affected the distribution, right? And so there's the really kind of the non-statistical reason why we can't do this, but it is a valid reason. Male versus female could have skewed it. Definitely Novia. Yes, exactly. Statistically, I want you to imagine, right? Let's I don't know if I can draw with this. Let me see if I can draw. Pen. All right. Let's say there's not this gap right here. And so these two are actually connected. So it brings them a little bit closer to actually an overall. But let's put our dark-haired people here, okay? I'm sorry about my drawing abilities. Okay, then scrunch those together. What it will look like is that there's a huge difference because here's our mean over here. Here will be our mean here. And here will our mean here, right? And so if we ran this through a statistical test, we would find this big difference. In fact, let's see, this would be an ANOVA. And so the value we would get would be something ridiculous. It would be like 1 to the 1000th power or something like that, right? Why? Because these two distributions are skewed. And so it looks like there is a huge difference between the three. But when we look at the median, that's closer. The mode, if we were to squish these two together, the modes would almost be the same. And so our statistical results will be flawed because we have two distributions that are skewed, okay? And so when we go down here, and this is the importance of the power analysis, is once we see these skewed distributions, then we go to a power analysis, and that will tell us how many more people or individuals that we will need to sample in order to make those two skewed samples become normal distributed, okay? And that's the importance of looking at the mean, median, and mode, is because when you come to statistical testing and everything, we need to make sure that those three are closely aligned with each other. They'll never perfectly be aligned with each other, but we need to have those as close together as possible, okay? So that's kind of the reason I did the exercise in the classroom, is just so that you know how to determine the mean, median, and mode, because from here on out, when I bring up examples of, let's say, a t-test that compares blondes and brunettes on helping behavior. And so you would use a t-test for that. But then if I were to give you some mean, medians, mode, what I want you to do is determine whether or not we can actually use that test or not to determine if there is a difference within the actual population, okay? And that's the importance of determining all three of those in your analyses, is because a lot of the analyses that we will do will demand, in a way, that the distributions be normally distributed, okay? Now, when we're just doing an exploratory study, and this is going to be the next question. So we're not going to do any inferentials. We don't want to know whether or not our sample relates to the population or not. We just want to learn about the conditions within a certain population. So we did a purposeful sampling, and we end up with skewed results. Those are also important when we're only looking at a single population within a single measure. Because let's look at this from this perspective, okay? What if I decided I'm not interested in comparing IQ scores. I just want to know about people with autism. Okay, I don't want to compare them. I don't want to know much more than that. I just want to know where their scores are on, let's say, let's go with an IQ test, because you all know, remember from previous lectures, that IQs are set at 100 with a deviation of 15. Okay. What if we found, and conjecture with me, what if we found that the mean score of individuals with autism is 90? So it's below the average for the population. And let's say the median score was 105 and the mode was 108. Would it be left skewed or right skewed? All right. So yes, it is left skewed, and I do have to put this out there. This is one of the things that confused me when I was first learning statistics, because when I first learned statistics, I always meant skewed meant that the majority was on one side versus the other, but the skewness comes from the tell. All right, so we tell skewness in whether the low end is here or the low end is here. Okay, and then the majority is on either this left side, which makes it right skewed because this is the skewed part. The majority is on the right side, which makes this tail down here the skewed area. Okay, and this was one of the biggest, I had problems with this one. So when I was going through statistics, I always got this answer wrong. So okay, so that's the meaning of skewness, is you want to look at where the longer tail is. Okay, all right, so going back to our example, in this case, in our autism case, this tells us a lot, that that there are on an average level, the score of IQ is lower. Okay, but as we see in the mean, median, and mode, that the mean is much higher and the mode is much higher. Okay, so just using conjecture, what would that mean about autistic children? And I'm going to use a different word than mean. What does it mean if the average is less than the majority, which is what median and mode really measure? Any guesses? All right. So you all are correct. It does mean from the mean, what this does tell us is that a good proportion of the population scored this direction. Okay. But there is a large population, because mode, remember, mode means most frequently recorded. All right. So maybe we have a mode, a high mode. So there's a high mode of people who score higher, and the middle point is higher, which means that, yes, while the majority of individuals with autism scored in the lower range, under 90, there is still a significant number of individuals with autism that score higher than the average, that score more than. And so what this tells us at this point, if you wanted to do this analytically, is that when we're looking at children with autism, and again, this is just an example, when we're looking within individuals with autism, we need to think of it as two separate populations. And maybe this is where we find that people are here above there. They are what we would consider special needs in the gifted range. And individuals under here, we would consider individuals in the deficiency range, right? And so what we're looking at, what we can really do with this type of analysis and say, listen, when it comes to research on IQ with individuals with autism, we're really dealing with two separate populations. We're dealing with a population of high functioning, and we're dealing with a population of low functioning. And I'm going to qualify this if we state that functioning is based on IQ scores. There's much more to that much more to an individual than IQ scores, but I couldn't find a different term at this moment. So what this can tell us when we're looking at an individual population is whether or not we actually have two separate populations that are experiencing two separate types of situation, and then we could go research that more. Does that make sense to everyone? And you could put it in the chat, yes or no, or speak it. Okay. Awesome. Okay. All right. Okay. All right. Okay. So that's mean, median, and mode. Does anybody have any questions right at this moment? Great. All right, great, because I wanted to leave at least some time at the end of this class so that you could go look at that other video on graphs and whatnot. So this is where we're headed. So I would like you to do the graphs video, okay? We went over mean, median, and mode and kind of how those three work together within the distribution. So now where we're going to head this coming Monday, if you want to read ahead in the textbook or whatever, is we need to look at variance, okay? And there's two types of variance that we need to look at, okay? Variance within our sample that we measured, which we usually use what's called the standard deviation, which again, the best definition I've heard is it's the average distance between individual scores. Okay, we need to look at that, and we talked about it a little bit when we looked at the distribution, and we saw that standard deviations can help us understand how many individuals fit within a certain range. Okay, but there's other purposes for standard deviation. The other thing that we need to look at, and oh, who brought it up? It's important. Yvonne, was it Yvonne? No, yeah, no. Let's see. I apologize. Someone bring up the idea of range, right? And so range tells us how widely dispersed the entire sample is. So we look at standard deviation, which is the average distance between individual scores, but then we're going to look at range, which is the range of scores for the sample that we took. Okay. And those are two important concepts to understand, because once we know what the average is, the middle point is, and whether the distribution is normal or not, and we know what the variance is between scores and between individuals and within the group, then we can start doing some of these analytical tools to say whether or not that sample represents the population, whether the differences are significant. We mentioned earlier in the class about correlations, about whether two things are associated to, but we have to do this pre-work first. The other variance statistic that we need to come up with, so that's the first one, determining what the distance is between individual scores and the distance is between everyone, which is range. The next thing we have to do, oh, Gabe, yes, thank you, Gabe. Thanks for bringing that up. The next thing we need to do is we need to look at our mean, okay? And we need to look at two things with our mean. One is the error of the mean, okay? Which at a basic definition, the error of the mean is the amount of error that probably is in our sample mean compared to our population mean. Meaning that, so if I get an error rate of, well, okay, here's a good example. Anybody has watched the weather, they will give a probability of whether it's going to rain today, okay? And they used to give a number of plus or minus 1 to 10, okay? I don't know if they still do that. I haven't seen that in quite a while, okay? But what they're telling you is, when they're telling you that it's going to be 98 degrees tomorrow plus or minus 2 degrees, is that's the mean of their error, okay? Meaning that their error in their mean is 2. Meaning that the population, let's say tomorrow they're predicting 90 degrees, the error in their 90-degree prediction is -2, which would be 88, +2, which would be 92. So that is the error range that our prediction has. Okay, that's error of the mean. Novia, that humidity is a perfect example of that. Yes. Do you want to elaborate on that? Because I think it's important.
No, I was just saying, like normally we see our temp, it'll say 91 degrees. And then when you check the humidity part, it'll say humidity 25%. And in another area, it'll say which will make it seem like 101 degrees.
Yeah. And so the reason why I think it's very important that you brought that point up, and not to complicate things, that feels as rate is because they entered humidity as what we call a mediator variable. Okay. What a mediator variable does is it changes the relationship between the independent variable, which in this case is temperature, and the dependent variable, which is what it should feel like, okay? The mediating variable is humidity. So what they do in this situation is they do a simple test and they enter humidity, the humidity level, into the mediation category, which will adjust that temperature up or down dependent upon it. But Novia, thank you for bringing that up. That's a great example of what we consider what we call a mediating variable, because it influences the relationship between what the temperature should be and what the temperature probably will be given the mediation of humidity. So I picked on you for a bit because I think that's a really awesome example of what we call a mediating variable. Thank you for that and bringing that up. Okay, so there's error of the mean, and then there's what we call I just forgot the name. Oh my goodness. Confidence intervals. Okay, so you have the error, and it can tell you a lot, but it has a lot of issues. They use it in weather, they use it in all different kinds of places, but it is not an exact measure of what the true mean is as far as what we call a confidence interval. A confidence interval uses the p-value to determine the range of where the true population mean is based on a sample size. So it actually gives you the range at a 95, we set it at 95% confidence of what the true average is within a population, okay? I'm gonna leave that there for now because it helps us when we're analyzing data, but just kind of keep that in mind, and we'll go over confidence intervals, error of the mean, standard deviation, and range next week, because after next week, we're going to start then testing data. And we'll do it as a class, and then I'll give some individual examples. But once we understand error of the mean, standard deviation, range, and then confidence intervals, then we can go on to say, this is how we actually test the data that you guys have proposed in the class. And we'll use those as examples of how to do that. So that's kind of where we're headed. The video, though, it's 23 minutes long, and we only have 15 minutes left in the class. So I do want to end the class kind of quickly here. Does anybody have any questions?
I do. So my husband is going to be the one who's helping me with the math and all that stuff of this class. How do I get access to your lectures? That way he can understand exactly what I'm talking about.
So Diana, you can access all of the lectures in the Canvas classroom under the module that it's under is called class lectures. And once we're done here, I download them all and then I post them right to the classroom so that you have them available to you. And so that's basically how you can access all the lectures. Now, all the assignments I'm hoping are written very clearly for everybody. That way you're able to get through them. So that's where you would look, you'd find them.
Thank you.
You're welcome. All right, everyone, let's get out of here so that we at least have 15 minutes of just lecture time, just so you can view the videos and start answering the questions and whatnot. So let's close up class for today, and we will see you all on Monday, at least virtually. If you have any problems with your assignments, if major issues come up in your life or something, please just let me know before the due date. Or if it's an emergency, soon after. That way I can keep track of everyone and where everyone is at, okay? So if you do me that favor, I'd appreciate it. Enjoy your weekend. Thank you, everybody.